13 vessels, 48 hours. A resupply corridor Russia had decided was untouchable, destroyed before the generals in Moscow even understood what was happening. This is the story of how Ukraine's Naval Special Operations engineers spent 3 months building a weapon Russia assumed didn't exist, and then used it to rewrite the tactical map of the Azov Sea in 2 days. I'm your host at Steel Horizon, where we analyze the battles that change wars. By July 2026, Ukraine had already done what the world once considered impossible. A country with no operational navy systematically dismantling one of Russia's most storied fleet presences using drone technology, ingenuity, and a combat doctrine that hadn't existed 5 years ago. The Black Sea campaign proved the concept, but Russia had adapted. Or so they thought. The Shadow Fleet, unmarked, sanctions-evading tankers ferrying fuel and supplies to Crimea's military garrison, had quietly shifted their routing eastward, into shallower water, into the Sea of Azov, where Russia's planners believed Ukraine's maritime strike capability simply couldn't follow. They were wrong, and the proof would play out across 48 hours in mid-July 2026 in one of the most concentrated naval strike campaigns of the entire war. To understand what made this operation work, you have to understand the geography Russia was betting on. The Sea of Azov is the world's shallowest sea. Average depth, roughly 7 meters. In the shipping lanes near Berdyansk and Mariupol, the 2 port cities Russia had held since 2022, depth drops below 4 meters in stretches. Standard maritime drone operations in the Black Sea had been built around different conditions: deeper water, stronger currents, a longer operational envelope. Ukraine's Magura V5 naval drone, the weapon that had already struck Russian warships in open water, was designed for those conditions. The standard Magura V5 was. What Ukraine's 73rd Naval Special Operations Center had been quietly developing since October 2025 was something different. The program began as an internal engineering problem. Analysts at GUR, Ukrainian Military Intelligence, had been tracking the Shadow Fleet's gradual eastern migration for months. The route shift was subtle at first, a tanker that had previously rounded the southern tip of Crimea taking a slightly different heading. Cargo manifests, when obtainable, showing fuel consignments originating from Russian Azov ports rather than Black Sea terminals. By November 2025, the pattern was clear enough that GUR's maritime analysis team flagged it formally. Russia was building an Azov resupply corridor, betting the sea's shallow depth would serve as a natural defensive barrier. The question went to the 73rd's Engineering Division within days. Could the Magura platform be modified for shallow water Azov operations? The answer, after 6 weeks of field testing at undisclosed locations along Ukraine's Azov coastline, was yes, but not without significant redesign. The standard Magura V5 carried ballast configurations optimized for deeper water. Its guidance systems had been calibrated for Black Sea acoustic and electromagnetic conditions. Its radar cross-section, already reduced compared to conventional vessels, had a specific signature profile that Russian electronic warfare systems in the Black Sea theater had been trained to recognize and track. The Azov-modified variant addressed all 3 problems. Lighter ballast reduced the drone's operational draft to under 0, 8 meters, letting it operate reliably in water depths down to 5 meters. The guidance package was recalibrated using Azov-specific acoustic data collected over months of passive monitoring, and the radar and acoustic profile was deliberately modified. Different materials on the hull's forward surfaces, different engine harmonic suppression, to produce a signature that didn't match the threat libraries Russian electronic warfare operators had built from 2 years of Black Sea engagement. Which weapon system proved deadlier in this campaign? The modified Magura drones, the pre-programmed Robo-Boat launch platforms, or the satellite reconnaissance network that made targeting possible? Comment below. The answer is more complicated than it looks. By January 2026, the 73rd had a working prototype. By March, a production batch. By May, a doctrine. A complete operational concept for deploying the Azov-modified Magura in a coordinated multi-wave strike campaign. What they didn't yet have was a confirmed target set worth the operational risk of revealing the capability. That changed in the first week of July 2026. Satellite reconnaissance. A combination of Ukrainian military assets and commercially available imagery that GUR's analysts had become highly skilled at processing. began flagging unusual activity near the port of Berdyansk. Tankers. Not one or two, but a cluster of them, anchored in a loose formation in the shallow water east of the main channel, cross-referencing with known Shadow Fleet vessel profiles, the unmarked or frequently renamed tankers that Western sanctions had failed to fully interdict. Guar's maritime team began building a picture. By July 8, 2026, they had confirmed 12 vessels. By July 10th, a 13th had joined the staging area near Mariupol. 13 shadow tankers. Intelligence assessment, fuel cargo destined for Crimea's military garrison. Combined estimated fuel value, enough to sustain Russian military vehicle operations across the Crimean Peninsula for approximately 6 weeks. The strategic logic was obvious. With land routes under constant Ukrainian pressure and the Black Sea corridor increasingly dangerous, Russia had concentrated a significant portion of its Crimea fuel supply into a single Azov staging operation, betting the geography would protect it. The 73rd's commander looked at the target package and made the call. This was what the Azov-modified Magura had been built for. The operational planning over the next 72 hours is, even by the standards of this war, remarkable. The central tactical challenge wasn't the drones themselves. The modified Magura had performed consistently in testing. The challenge was deployment logistics. Operating 60 kilometers from shore, in shallow water, against targets that Russian patrol assets were actively protecting, required a solution to a basic problem. How do you get strike assets into position without alerting the enemy's electronic surveillance network? The answer was the Robo-Boat platform system. Ukraine had been developing autonomous surface vessel platforms, unmanned boats capable of carrying payloads and operating under pre-programmed navigation, since at least 2024. The concept had been tested in various configurations. What the 73rd refined for the Azov operation was a distributed carrier grid, multiple autonomous surface platforms, each capable of carrying 2 Magura strike drones, pre-positioned at staggered coordinates across a 60-kilometer operational zone. The platforms operated under complete radio silence once deployed, following pre-programmed navigation routes to their designated launch positions and then holding station, waiting. The critical factor was timing synchronization. Each platform carried strike coordinates fed from satellite reconnaissance exactly 90 minutes before the planned launch window. The 90-minute interval was deliberate, long enough that the coordinates reflected current target positions based on updated imagery, short enough that target movement since the last update would be minimal given the anchored Shadow Fleet. There was one problem that nearly derailed the operation before it began. In the final 48 hours before the planned launch, Ukrainian signals intelligence detected an increase in Russian electronic warfare activity in the eastern Azov sector, not specifically directed at the planned strike corridor, but a general increase in radar sweep frequency and jamming pulse activity that suggested Russian patrol assets had picked up something, possibly the earlier pre-positioning of the autonomous carrier platforms. The 73rd's operational planners faced a hard choice: abort, delay, or accelerate. They accelerated. The launch window moved forward by 4 hours, compressing the final coordination timeline and accepting reduced margin for last-minute target verification. It was a calculated risk. If the Russian EW activity was a response to detecting the carrier platforms, waiting meant potentially losing the platforms entirely. Moving early meant launching before full confirmation that all 13 target vessels remained in their last confirmed positions. Stay with me, because what happens in the next 18 minutes after that first launch destroys the foundation of Russia's entire Azov resupply strategy. At 11:23 p.m. on July 11th, 2026, the first wave launched. 8 Magura drones, departing from 4 carrier platforms positioned in a staggered arc, 62 kilometers northeast of Berdyansk, moving at reduced speed to minimize acoustic signature in the shallow water. Russian electronic warfare systems in the area were running active sweeps. The Azov-modified Magura's altered signature profile was about to face its first real operational test. For the first 40 minutes, nothing. The drones moved through dark water on pre-programmed routes, acoustic and radar signatures below the detection threshold of Russian systems tuned for profiles they'd learned from 2 years of Black Sea engagements. The carrier platforms, mission complete, began their automated return routes. At 12:04 a.m. on July 12th, the first Magura reached its target. The detonation of the first shadow tanker, later identified by Ukrainian intelligence as a vessel that had operated under at least 4 different registered names, lit up the eastern Azov dark. Russia had 6 hours before dawn, and no idea what was coming next. The initial Russian response was exactly what the 73rd's planners had anticipated. Azov patrol vessels scrambled from Berdyansk. Russian electronic warfare operators ran intensive sweeps, but they were searching for Black Sea Magura signatures and finding nothing. Intercepted communications, later published by Ukrainian military intelligence, showed Russian naval command in the Azov sector cycling through threat assessments in real time. Ukrainian surface attack? Underwater mine? Equipment failure on the tanker? A modified Magura operating in Azov shallow water was, apparently, not on the initial list. The 2nd through 8th strikes came in rapid sequence between 12:04 a.m. and 6:17 a.m. 7 more shadow tankers hit. Russian patrol vessels, responding to the first strike and moving toward the Berdyansk staging area, were navigating directly through the operational zone, making themselves easier targets for the strike drones, not harder. The Azov patrol fleet's movements were logged by Ukrainian reconnaissance assets and fed back to the 73rd's command cell in near real time. By dawn on July 12th, 8 tankers had been struck, some burning, some taking on water. The Mariupol staging area, where 5 of the 13 target vessels were anchored, had erupted into chaos, with Russian port authorities attempting to move undamaged vessels out of the target zone while simultaneously dealing with fires aboard the damaged ones. Here's what stands out about this phase. Russia's Azov patrol fleet, by responding aggressively and visibly to the first strikes, actually made Ukrainian targeting easier. Every patrol vessel that moved became a trackable signature. Every emergency communication created an interceptable signal. The aggressive response, flooding the operational area with assets, was exactly the wrong tactical choice against a strike system using passive pre-programmed guidance rather than active command links. How many shadow fleet tankers did Ukraine strike in total during this 48-hour operation? A. 9 tankers. B. 13 tankers. C. 7 tankers. The answer comes at the end of this video. But the number alone doesn't capture how this changed Russia's supply calculus. The pause between the first and second waves lasted approximately 14 hours. This was not hesitation. It was deliberate. The 73rd's operational concept had built in a second wave delay specifically to exploit Russian behavioral patterns. After a major strike event, Russian command tends to cycle through immediate response, damage assessment, threat identification, and then a stabilization period where patrol activity peaks and then gradually relaxes as the immediate threat appears to have passed. The 14-hour gap was calibrated to catch Russian Azov patrol assets in that relaxation phase. It worked. At 2:41 a.m. on July 13, 2026, the second wave launched. 5 more Magura drones from 3 carrier platforms that had been pre-positioned during the first wave's operational window. Different coordinates, different approach vectors. Russian electronic warfare assets were still active, but the sweep patterns had shifted, focused on the areas where the first wave strikes had occurred rather than covering the broader operational zone. One of the second wave platforms experienced a navigation fault approximately 30 kilometers from the target zone. The pre-programmed route brought it within 50 meters of a shallow sandbar that hadn't been accurately mapped in the satellite data used for coordinate loading. The drone grounded. 1 strike asset lost. 4 proceeded. The remaining 4 Magura struck the final tankers in the Berdyansk and Mariupol staging areas. The last confirmed hit came at 5:58 a.m. on July 13th. 13 Shadow Fleet tankers struck across 48 hours. The Mariupol fuel staging area was, according to Ukrainian military intelligence's subsequent assessment, functionally destroyed as a logistics node. Here's the part that doesn't make sense on the surface, until you look at the electronic warfare dimension. Russia's Azov EW assets had been assessed by Ukrainian intelligence as among the most capable in the theater. They had detected and disrupted multiple Ukrainian drone operations in the Azov sector over the preceding 18 months. What they hadn't encountered was a drone designed to look like nothing they'd been trained to recognize. The Azov-modified Magura didn't defeat Russian electronic warfare by being stealthy in any conventional sense. It defeated it by being unfamiliar. The threat libraries Russian operators were working from didn't include its acoustic and radar profile. They were looking for a known threat. Ukraine had sent them an unknown one. Subscribe to Steel Horizon if you want to understand how modern warfare actually works, because this pattern keeps repeating across every theater of this conflict. The intercepted Russian communications that Ukrainian intelligence later published are, frankly, extraordinary reading. In the 6 hours following the first strikes, Russian Naval Command in the Azov sector sent 47 separate message traffic items attempting to identify the threat. The working hypothesis for the first 4 hours was mines. Specifically, that Ukraine had somehow preceded the Berdyansk and Mariupol staging areas with drifting mines in the preceding days. It was only when the strike pattern didn't match mine deployment logic. The hits were too targeted, too sequential, too clearly directed at specific vessels, that the drone hypothesis emerged. By the time Russian EW operators had recalibrated their detection parameters to account for the modified Magura signature, the first wave was over. The second wave launched before the recalibrated parameters could be widely distributed across the Azov patrol network. The 3-hour delay in getting updated threat signatures to forward EW assets, a product of Russian command communication protocols that prioritize security over speed, meant the second wave hit before Russian operators had what they needed to detect it. If you believe tactics win wars, type Steel Horizon in the comments. I spent hours going through the published intercepts and the subsequent Ukrainian intelligence assessments, and one detail kept coming back to me. As recently as 72 hours before the first strike. 72 hours before the operation that destroyed 13 of Russia's Shadow Fleet tankers. Russian Naval Command had formally classified the Sea of Azov as, and I'm quoting directly from the published intercept, a non-threat corridor for resupply operations, with an assessed risk level of minimal, based on Ukrainian drone, operational parameters, and Sea of Azov bathymetric constraints. Non-threat corridor. That's what they called it. 3 days later, it was a graveyard of burning tankers. Here's the take that might get some pushback. Russia's failure here wasn't primarily tactical. It was institutional. The assessment that the Azov was a non-threat corridor was correct, given the information Russian analysts had available. Ukraine's Magura platform, in its standard configuration, genuinely couldn't operate effectively in shallow Azov conditions. The intelligence failure wasn't incompetence. It was the assumption that Ukraine would be constrained by the limitations of its known systems. Russian strategic planning consistently underestimates Ukrainian engineering adaptation. It did it with the Black Sea drone campaign. It did it with HIMARS employment. And it did it here. When this war is eventually studied in military academies, this pattern, Russian planners assessing Ukrainian capability based on what Ukraine has publicly demonstrated, then being surprised by what Ukraine has been quietly developing, will be one of the defining doctrinal lessons. The damage assessment from the 48-hour Azov campaign is still, as of July 25, 2026, being fully compiled. Ukrainian military intelligence's published figures indicate 13 Shadow Fleet tankers struck, with at least 9 assessed as total losses based on satellite imagery analysis of their condition in the days following the strikes. The estimated fuel cargo destroyed represents approximately 6 weeks of Crimea garrison supply at current operational tempo, a figure that aligns with assessments from Western defense analysts monitoring Russian logistical posture. What do you think? Was the decision to concentrate 13 tankers in a single Azov staging area a critical strategic error, or was Russia right to bet on the geography? Comment with your analysis. The Mariupol port infrastructure used as the primary staging node suffered what Ukrainian sources describe as severe damage to the fuel handling facilities beyond the vessels themselves. Whether that assessment will hold as additional imagery becomes available remains to be confirmed, but the operational disruption to Russia's Azov resupply corridor is not in question. Russian shipping traffic through the eastern Azov has, according to satellite tracking services monitoring the Shadow Fleet, dropped to near zero in the 2 weeks following the campaign. The corridor Russia's planners classified as untouchable has been effectively closed. What would NATO have done differently with these strike assets and this target set? Comment your analysis below. The broader strategic implications extend beyond the tankers. Ukraine's demonstrated ability to operate precision strike drones in shallow Azov conditions changes Russia's defensive calculus for the entire eastern Azov coastline. Every port facility, every logistics staging area, every fuel depot within 60 kilometers of navigable Azov water is now within Ukraine's demonstrated strike envelope. Russia cannot classify any portion of the Azov as a non-threat zone again. The modified Magura has proven otherwise. Russia's response options are limited and expensive. Deploying sufficient patrol assets to make the entire Azov operational zone genuinely dangerous for Ukrainian strike drones would require resources currently committed elsewhere. Installing physical barriers, nets, chains, shallow water obstacle fields in the approaches to key Azov port facilities is technically feasible, but logistically demanding and publicly visible, providing immediate intelligence value to Ukrainian planners. The most likely Russian response: upgrading EW assets with the updated Azov-modified Magura signature profiles is already in progress, according to Ukrainian intelligence assessments. But as this campaign demonstrated, signature adaptation is an iterative process. Ukraine can modify again. There's a line in the published Ukrainian intelligence summary of the campaign that reads almost like something out of a strategy textbook rather than a combat after-action report. The summary notes that the operation's primary value was not the tankers destroyed or the fuel denied. It was the demonstration that no body of water adjacent to Russian-occupied Ukrainian territory can be treated as beyond Ukrainian reach. The psychological and operational impact of that demonstration, the summary argues, exceeds the direct material damage by an order of magnitude. It's a striking claim. And looking at Russia's behavior in the Azov corridor in the 2 weeks since, it appears to be accurate. One detail from the after-action reporting stayed with me more than any other: the navigation fault that grounded one of the second-wave Maguras on a sandbar 30 kilometers from target, the one strike asset lost in the entire operation. The 73rd's planners had built the route using satellite-derived bathymetric data. The sandbar that wasn't accurately mapped in that data is estimated to be less than 50 meters wide. One sandbar, 50 meters wide, in a 60-kilometer operational zone. Everything else worked. 12 of 13 drones reached their targets. The carrier platforms recovered successfully. The radio silence protocol held for the entire operation. No operational communications that Russian signals intelligence could trace back to the launch coordinates. 3 months of engineering work, 6 weeks of field testing, 72 hours of operational planning, and a 48-hour strike campaign that Russia had declared impossible. That's what modern Ukrainian warfare looks like. Innovation is a force multiplier. Will Russia find a way to close the Azov corridor to Ukrainian maritime strike operations within the next 6 months? Comment why yes or no. The engineering race is very much still running. The 73rd Naval Special Operations Center's Azov campaign didn't just destroy 13 tankers. It destroyed a strategic assumption. Russia had been building its Crimea resupply logic around the premise that geography, specifically the shallow Azov, provided a buffer that technology couldn't bridge. Ukraine spent 3 months proving that assumption wrong and 48 hours making that proof permanent. Ukraine doesn't just use weapons. Ukraine invents new ways to fight. And that brings us back to the question this campaign poses for every military force studying this conflict. In the modern battle space, the defining competitive advantage is not the weapon you currently possess. It is the speed at which you adapt that weapon to meet the conditions the enemy believes you can't operate in. Ukraine has demonstrated this consistently in artillery employment, in air defense integration, in ground drone tactics, and now in maritime strike operations. Each time, the sequence is the same. Russia identifies a presumed safe zone. Ukraine develops a solution in 3 to 6 months. Russia discovers the safe zone doesn't exist. The Sea of Azov is the latest example. It won't be the last. Real battles, real tactics, real consequences. Steel horizon. Now, the answer to this video's tactical quiz. How many Shadow Fleet tankers did Ukraine strike in the 48-hour Azov campaign? The answer is B, 13 tankers. 9 were assessed as total losses by satellite imagery analysis. 4 sustained significant damage. The combined fuel cargo loss set Russia's Crimea resupply timeline back by an estimated 6 weeks. The correct answer matters beyond the number itself, because 13 vessels in 48 hours in a sea Russia had declared off-limits to Ukrainian strike operations represents the highest per-unit naval strike success rate of the entire war to date. 3 questions to take with you. Was concentrating 13 shadow tankers in a single Azov staging area the right strategic choice for Russia? Or did the logistical efficiency of the corridor create an unacceptable vulnerability? The geographic logic was sound. Azov shallow water was a genuine constraint on standard Ukrainian maritime strike systems. The failure was assuming Ukraine would accept that constraint rather than engineer around it. Could Russia have detected and disrupted the operation with different electronic warfare protocols? Almost certainly. The Azov-modified Magura's signature gap existed specifically because Russian EW systems had been optimized for Black Sea drone profiles, a broader, less operationally specific threat library, maintained through continuous updates rather than theater-specific tuning, would likely have flagged the anomaly. The EW failure here was doctrinal, not technical. What would you have done differently as the commander of the Russian Azov patrol fleet? Spread the tankers across multiple smaller staging areas, reducing concentration risk? Increased patrol density specifically around the staging zones? Commissioned an independent assessment of the Azov threat before classifying it as a non-threat corridor? The options existed. The command decisions were different. The results are burning on the Azov floor. Subscribe to Steel Horizon, because we break down the battles that textbooks will study for decades. The Sea of Azov is quieter now than it was on the morning of July 13th, 2026. The fires are out. But the hulks of 13 shadow tankers remain in the shallow water near Berdyansk and Mariupol. Silent reminders that in this war, no corridor is safe, no geography is protection, and no assumption about what Ukraine can't do survives contact with what Ukraine has been building while no one was watching. Modern warfare punishes tactical complacency without mercy. Stay vigilant.